Today we're going to be solving radical equations. Call that because you've got a square root sign or some sort of radical up there. So the goal when you're solving radical equations is to get the square root part by itself, to isolate this radical. Because once we isolate the radical, we know how to undo a square root. Square root is kind of the inverse of squaring. So to undo this, we're just going to square both sides. So we get 16 equals x plus 3. The square root just kind of pops off because we undid it with that squaring. So x plus 3 equals 16. Now we're going to subtract 3. X equals 13. Okay. The next step that you need to do, you really need to check these, and we'll talk about why you need to check these in just a moment. But 13 plus 3, that's 16. Square root of 16 is 4, so we are good to go. That is a valid solution here. Let's try another one, okay? Very similar problem, except for this is negative. So we to undo this square root, we square both sides. We get same thing. X plus 3 equals 16. X equals 13. Okay? Looks great. Looks easy. We plug it in. 13 plus 3 is 16. Square root of 16 is not negative 4. Now, in this case, we really should have seen red flags from the very beginning. We see that the square root of something is equaling a negative, but it can't do that. So even though we got a solution by what looked like good algebraic means, this is invalid. Okay, this is called an extraneous solution. I'm going to talk really quick about why this happens. So if x equals 3, if that is true, then it follows that x squared will equal 9. This statement implies this statement. Unfortunately, it doesn't work the other way around. If x squared equals 9, that doesn't mean that x equals 3. It could mean that x equals 3. It could mean that x equals negative 3. Whenever we square both sides here, we create an extra solution. And sometimes that solution is valid, and sometimes that solution is invalid. So whenever we do that step of squaring both sides, we need to check the validity of our solutions, because even though this makes this true, this doesn't always make this true. Okay? One more real quick. This is different because it's not a square root, it's a cube root. Don't stress out about this, y'all. All this means is instead of this undoing squaring, it's undoing cubing. It's the inverse operation of cubing. To undo a cube root, we just cube both sides. Okay, so again, since we did the inverse operation, that just pops right off. 2 to the third, be careful, that's not 6, it's 2 times 2 times 2. So in this case, that would be 8. And now we add 3, we get 11. X equals 11 over 6. You probably won't need to check this because it's a cube root, but let's just do it since we're in the habit. 11/6 times 6 times 6 divided by 6 cancels out, so it's 11. So we get cube root of 11 minus 3. Cube root of 8 is 2. 2 cubed equals 8. Okay, so this is a valid solution here.